Alright, so we're going to talk a little bit more in depth about integrals. And these are the two general forms for integrals. So we have what's called a definite integral, and then we have an indefinite integral. And the definite integral is, you can kind of see the difference here, is going to be the definite integral has this a and b, whereas the indefinite integral doesn't have that. And we call those upper and lower limits. And the definite integral, it's basically saying this is going to be all of this space between a and b. And so it's going to be a specific area under the curve, which means it will give us an actual numerical answer because it is a specific section of the curve. It is some area. So our answer will be numerical. When we do the indefinite integral, okay, that's going to be basically everywhere under the curve. If you keep going everywhere under the curve, everywhere. And so that's not going to be an answer because we don't know what section of it is. It's more going to be a formula to tell us if we do pick out a section, we'll get there. So it's more of an algebraic answer. And that's kind of the difference between a definite and an indefinite integral. And the indefinite one, it just doesn't have an upper or lower limit or bound. So we're going to do a couple examples here. So first we're just going to be talking about what an antiderivative is and kind of thinking about it. And what I want you guys to think about is, like, if we started off with x squared, well, we can go down the derivative ladder, right? The derivative would be 2x. The second derivative would be 2. After that, the derivative would be 0, and then it just, that's the end of it, right? If you kept taking derivatives, it would be 0. But I kind of think of it almost as a ladder, like a step ladder. And if we wanted to think, okay, well, what's above x squared, right? What's up here? What, if we took the derivative of what, would we get to x squared? And that is the integral. Kind of going backwards is an integral. So the integral of 0 could be 2. The integral of 2 is 2x. The integral of 2x is 2x squared, and so on. And I want to point out that could be, we'll get there later, because the derivative of any constant is 0. So basically, though, the antiderivative of x squared, it's another word for integral, right? This is what we're looking for right here, is in that box. So if we look at these, like if we look at from 2x to x squared, right? So dx, the derivative of x squared is equal to 2x, right? Well, now if I want to go backwards, if I take the integral of both sides, well, when we take the integral of this derivative, what actually ends up happening is they cancel out and we're back to x squared, right? So when we take the integral of 2x, we need to get back to x squared. Well, what I want you guys to think about is, how could I get from 2x to x squared? So I'm starting at 2x. I want to get to x squared. What do I have to do mathematically? Well, this is like 2x to the first power, right? And we need to get that first power to be to the second power. So we're going to add 1. And then we want to get rid of the coefficient. We want to simplify it out. So we're going to divide by 2. And that's kind of, the general theory. We'll get more into it later. But basically, we know if we're going to take the integral of x squared, right, because that's what we asked you to do, or I asked you to do, is it is going to go up the ladder, right? Right here, it's like x to the 0th power, x to the first power, x to the second power. So we can probably make a good educated guess that this integral is going to have some x cubed in it. So I'm going to put, we know it's going to be x cubed, right? But we also know, that when we take the derivative of x cubed, we get 3x squared. Well, we don't want that 3 there. So I'm going to divide this by 3 so that now, if I plug this into that ladder, okay, so if I plug this into that ladder, we have x cubed over 3. If we go down, right, the derivative of that, we bring the 3 up to the front, 3x squared over 3. It is x squared, so this was the derivative. However, there's one thing I want you guys to think about, and that's What about the constants? So if I had a constant in there, like x cubed plus 4, would that be the same thing? Well, yeah, when I take the derivative, the 4 goes to 0, so it would still be x squared. What about x cubed over 3 minus 72? We'd still get, when we take the derivative, x squared. What about x cubed over 3 plus 980? Really, anything, right? So we call this a family of antiderivatives, and it's basically, x cubed is this thing, right? So the family of antiderivatives, is that, I can't draw it completely well, but anyways, they should all be x cubed, and we're just moving them up and down. So this is the family of antiderivatives. They're all going to have the same integral. Okay, which makes sense because they should all have the same slope also at any point. An integral is just the opposite of a derivative. So our real answer is going to be x cubed over 3 plus some constant c. We don't know what that constant is. And any time we have an indefinite integral, so anytime we have an indefinite integral, we're going to have to add that c. When we get to definite integrals, we won't, but we'll talk about those later. So indefinite integrals, we're always going to be adding c. That's one thing that's very, very easy to forget on an AP test, but it's extremely important to remember. So we're going to do 2 examples, actually 3 more, but 2 more really important ones. The first one is the constant rule, and the constant rule is kind of the same thing from derivatives. If we wanted to do the derivative of 5x squared, that's the same thing as 5 times the derivative of x squared. Same concept applies to integrals, and that's if you ever have a constant in an integral, you can basically just bring it to the outside. So this would be the same as 5 times the integral of cosine of x dx. And now we want the integral or the antiderivative of cosine of x. So what, if we take the derivative of what function will it give us cosine of x? Well, if we think about it, right, cosine of x, the derivative is negative sine x, and then the derivative of that is negative cosine of x, derivative of that is negative sine x, and then the derivative of negative sine x is actually cosine of x again, or we could just bring it all the way back around, right, because this one repeats. So, this was positive sine x. The derivative of negative cosine x is positive sine x. The derivative of positive sine x goes back to cosine x. So, the antiderivative of cosine of x is backwards on that step ladder, like backwards right to sine x. So this will be 5 times the antiderivative of cosine x will be sine x plus c. And now a lot of people think that, okay, we should then distribute, right? So we'll have 5 sine x plus 5c. But if we think about what the definition and really the spirit of a constant is, it's just some number that's not changing. So when we call it c, it's because it's some number we don't know, it's not changing. Well, if we multiply that number by 5, it's still some constant number we don't know about, right? If it was 3, the constant is now 15. If it was 10, the constant's now 50. But at the end of the day, it's still a constant. So what we actually do is we don't write 5c, we just write c still. So 5c is equal, you could call it c prime. It's like, this c over here is different than that c. But at the end, it's still a constant. So our answer will be 5, or our solution will be 5 sine x plus c. Or if you want to call it c prime, you can call it c prime. So that is the integral. And if you can always test this, right? Just take the derivative and make sure we get back to 5 cosine of x. So if we do the derivative of 5 sine x plus c, we get 5 cosine x, and the derivative of c goes to 0, which is what we started with. So yes, that worked. All right, now the last one is the anti-power rule, and this is really the big one I want you guys to know about. And when we think about integrals, usually you think of the anti-power rule. And this is very similar to example 1, what we talked about up here with, adding 1 to the exponent and dividing. And we just want to come up with a general rule or general formula for this. So if we have some x to some nth power, right, so x cubed, x squared, x to the 7th, anything, this is what we want. We want to come up with a rule or a formula for that. And so if we start off, right, we have x to the n. If we went down on that ladder, right, we'd get n times x to the n minus 1. Well, remember, an antiderivative is just going back up the ladder, going backwards. So how could we get backwards back to x to the n, starting off with n times x to the n minus 1? Well, we have to, first we will divide by that n, and then we will add 1 to our exponent. Now, really, okay, what we're doing, if you look at the exponent, because what we have here, we only have an exponent, is we're dividing by 1 more than this, right? It's n minus 1 plus 1 is what we're dividing by. We're really actually dividing by this whole thing, but then minus 1 plus 1 goes away. But I want to point that out because if we want to go up 1 more step, okay, what's going to end up happening with our anti-power rule is that we're going to take our x to the n term, and we're going to add 1 to that exponent, but then we're going to divide by that whole thing. We're going to divide by that n plus 1. And the reason for that, so this is the anti-power rule. This is how we take integrals, and what I want you guys to think about when we're taking integrals is this is the formula, x to the n plus 1 over n plus 1. That's the formula. And the reason why is if we take the derivative of this, right? So x to the n plus 1 over n plus 1. If we want to go down that step ladder again and take the derivative, right, the n plus 1 comes to the front. So we get we'll get n plus 1 times x to the n plus 1, right, minus 1. So x to the n over n plus 1, and the n plus 1's cancel. So this is our formula right here. And if you feel comfortable with this and you really understand everything, go ahead and stop the notes right now. I'm going to do one quick 1 minute example just on doing one of these. So example 4 will be, what is the integral? Oh, you know what? I did make one little tiny, I forgot about what I told you guys you shouldn't forget about. And that's we always have to add c. So make sure we're always adding c. So now we'll do this example. So the integral of, say, 3x to the 5th power dx. And now what we're going to do is we're going to apply that anti-power rule. So first we'll actually apply the constant rule, and I'll take that constant out. And we'll have 3 times the integral of x to the 5th dx. And now we'll apply the anti-power rule, and we'll have 3 times x to the 6th over 6, right? We add 1, and then we divide by that. And then plus c. And then now we can simplify by 3, and we get x to the 6th over 2, or 1/2 x to the 6th plus c. And that's really it. So come tomorrow with any questions, and I will see you in class. Have a good one.